Okay, so there are 5 major cases for partial fractions. Okay, so the first thing that needs to be done is you need to be able to factor. There's going to be a lot of factoring in this section. So you look at the denominator. And we're going to do this together in a second. You factor it and you get these two. Can you see my pointer or no? Okay, so you factor into 2 distinct factors. See how they're not the same, they're not repeated. We have an x plus 3 and an x minus 2. They are 2 different prime factors. They don't factor anymore. When you have this situation, you can set it equal to a over the first one plus b over the second one. Now, it doesn't matter what the order is, but that's usually what we do. And that's it. This is the setup. This is half the credit on your exam. Just can you remember which case we got and how we set it up? Okay. The other half is doing all this work to solve for a and b, which we'll do soon. Okay. Does everyone see this first setup? Okay. We'll talk about it some more in a minute. The other one, I'll write this down on the paper in a few minutes. Here we have repeated linear factors. So you look at the denominator, you factor this, and you end up getting here. So I'm going to show you the steps on how to factor. Notice how there's an x minus 1 squared, right? Once it's all said and done, you have it ready. X and x minus 1 squared are technically two different factors. So you have a over the first one, b over, and then this is where it changes because it's repeated. Repeated meaning you have a power higher than 1. Okay. So when that happens, you got to do b over 1, c over 2. So you count up to whatever number is right here. So if that was a 3, you'd go up to d over x minus 1 cubed. So you'd go 1, 2, 3. Does that make sense how the repeated is dealt with? Okay, so that's pretty much it for repeated. Again, I'll write it down in a moment. Distinct quadratic factors. This is just a big overview real quick. Again, it needs to be factored first. The second term right here cannot be factored further. So you have to write it as a over the first term, right? A over x minus 1 because that's distinct. But then the next one, because it doesn't factor further, you do bx plus c. So this is another case, another technique for this type of scenario. Okay, so if they're linear, we do what we did up here, right? A and b. If it's a linear that repeats, well, you do the same thing, a, b, and whatever, but you have to do it up until whatever number you got. Over here, we have one that doesn't factor, so you have to do bx plus c. Okay. Case 4. When you repeat quadratic factors, so this is basically combining rules 2 and 3 at the same time. So notice how they're going up to 2. So here's the 1 and then the 2. Okay, 1, this one, 2. But they're both factors that cannot be factored any further. It's a quadratic type. So you do ax plus b for the first one, and then you go cx plus d for the next one. So that is the setup. Okay. Case 5 is the most annoying one because it requires a long division. So we got to do long division with algebraic terms. So this is the one that really sucks. I don't like this one, but sometimes we have to do it. And we're going to have to remember the division algorithm, like just old school dividing by numbers on paper. We're going to have to go over that again, just in case you forgot. I know that sounds silly, but you're going to see why. So let's go over case 1 together. Okay. So that's the paper that I should put in your chat box. So I'm going to write down case 1. This is 9 point, I forgot 4, right? So okay, can you guys see this okay? Let me know if you can't read something because my handwriting is garbage. I worked on it. They worked on it for. Okay, so decompose. So that's this is what we're technically doing. We have a fraction and we're trying to break it into two separate fractions, right? Okay. So basically, if this was in numbers, this is what we're doing. And right, we know that 6 is 2 times 3, right? So what you can do is set that into some number plus some other number and separate. So you can actually separate these two numbers into two separate fractions. Usually we can't do that with fractions, but we can if we use this technique. So we're going to use this idea on algebraic terms. Okay. Case 1. Distinct linear factors. So all we mean by that is that we have more than at least one or two factors that are different but linear. That's it. Okay. You guys remember how to factor this type of stuff? This denominator. I know we don't have the answer in front of us, but do you know how to do it? This is a 5, by the way. Okay, so if there's no number in front of the x squared, we can do trial and error or brute force. That's the easiest technique for this type of factorization. Because we know that the first one has to be an x for both factors, right? Because that's the only way to get x squared. Now, we look at the factors of the -6 and figure out which of those add up to the constant on the x. Just a quick review. Put the factors here of -6, 2 and -3, -2 and 3, -1 and 6, 1 and -6, right? So you just write down all the factors to get -6, and then you sum them over here. 2 minus 3, -2 plus 3, -1 plus 6, 1 minus 6. So here are the answers for adding these up, adding the factors, not multiplying. So then you choose the one that adds up to the number in front of the x. There is no number, so it is implied to be a 1. So these are the numbers that we're going to use. These are the answers. So -2 plus 3. And that's what they had earlier, right? You guys remember doing this. I'm sure you've done it many times. And there's many different ways. I think now in high school they talk about some square method. I don't know what that is, but it's all the same to me. You can use whatever method you like. There's many of them. Okay. Any questions on factorization? Okay, because this is old stuff, so let me know. I don't want to say too many steps. But if you're cool, we'll move on. Okay, so these are linear factors, right? There's no powers on them. It's assumed to be a power of 1 on both. So the rule is that you can put a over the first one plus b over the second one. So this would be the setup. Okay, you know what? You write it all together. So when this is factored, I'm going to write the way they did just so it's the same. Not that it matters, but just so we can check our answer, not worry about it. But at the end of the day, if you were to switch them, your A would be different from their A, but at the end of the day, you'd have the same solution. It's just that A and B have been labeled opposite. Does that make sense? If I switch these. But it does not matter. I'm just doing this so if you're following along on the paper, it'll be the same. Anyway, so there is a setup. So that's 50% of the credit I'm going to give you if you can remember what case it is and how to set it up. Any questions on the setup? Okay. We'll come back to solving them in a second. You know what, let's go ahead and do it now since we already did an overview. So, okay. So now every single time for all of the cases, what you're going to do is multiply both sides by the LCD. So multiply both sides by the LCD. In this case, is the LCD. And notice we have two prime factors, right? So, and these have the same factors. So the LCD of all three of these is going to be this. So every single time one of these examples, the LCD will be this denominator. Okay, if you don't want to think too hard, just say, you know what, I'm just going to multiply both sides by whatever's down here. That will always work for this section. And we're gonna, and it's always going to cancel out the left-hand side. Okay, LCD is these two pieces. Okay. So take, I'm going to write every single fraction and multiply it by that LCD. So that's the left-hand side. Now the other fraction, the first one, on the right-hand side, multiply by x plus 3, x minus 2. And then the b term, x plus 3, x minus 2. So the left-hand side will completely cancel, leaving you with just the 5. Okay. B on this one, and the x plus 3's will cancel, leaving me with the a times x minus 2. So this is basically just clearing out fractions. It's technically what we're doing. Excuse me. You guys cool with the algebra from here to here? Any questions, or if I went too fast or if I make no sense, please let me know. I'll wait a bit. I don't want to go too fast either. Good. You guys are good then. So at this point, you need to solve for A and B. There's two methods. The one I'm going to show you works every single time. There is a shortcut method that works sometimes. Those are usually good for the easier types of questions. Like this one would be great for the shortcut method, but I need to show you the general method first. Okay? If you want to have two methods, that's up to you. It doesn't matter to me. So here we go. First thing you got to do is distribute your A and B and gather all your like terms together. Just put them next to each other. So AX, A times X, A times -2, B times X, B times 3. So now I get everything that has an X together. Everything that has an A, or sorry, these are like your constant terms. These are your linear X terms. So I put those together. Okay. So all I did. I multiplied and then I gathered them together. So get all like terms together. Okay. So step 1 is obviously set it up. Step 2 is cancel your fractions. And then step 3, we start to get ready to equate the coefficients. Any questions so far? I'll put a step 1 here. This is step 2. This is step 3, technically. Okay, sorry, I'll be more a little more neater on the next one, but should have labeled that earlier. So now we need to equate the coefficients. So that means, well, let me set it up for you. If you factor an X, right, do you agree that this is basically like saying 2x plus 3x, right? In other words, 2 plus 3 or A plus B. Does that make sense? And these are just some constants. So what you do is you say, okay, well, I'm going to equate this coefficient to the coefficient on the left-hand side over here, where the 5 is, to these two. Do you see any X terms on the left? We don't have any, right? So what you're going to do is say, okay, well, the coefficient of the left-hand side is going to be equal to a 0. So these right here equal to 0 because there is no X. Okay, and then you look at these, like, okay, well, these are constants, and we have a constant, right? So you say negative 2a plus 3b equals to 5. So that's called equating the coefficients. Right? So I create a system of equations. Any questions on setting this up? Okay. At this point, you can use any method you like to solve for A and B. You can use a graphing calculator or a scientific or a website or substitution or elimination or do a matrix by hand. I don't care how you do it. Solve for A and B. This class is not about testing your matrix stuff. That was college algebra. So I'm going to assume you know how to solve this. You need me to show you, I will. What I recommend though, is to change this into a matrix. Do you guys remember how to change a system into a matrix? Pretty sure you did it in college algebra. Right? So the first column goes here in the matrix, right? So it was the coefficient of the A, coefficient of the A, coefficient of the B, B. So if you have your whole numbers, you're on the right-hand side, and all the variables in order in the left-hand side, you just go straight to here. If it's set up, organized, I guess. Okay. So at that point, I would just use a graph calculator or a solver. I like using this one. We can do it by hand, but who cares? I like this guy here. I'm going to throw this link in the chat box. If you want to use it, you can. This is what I'm using right now. So you need to remember what matrix dimensions are if you're going to use a matrix solver. It's always row by column. The old books would say RC cola, row, column. So we have 2 rows, 3 columns, right? Matrix that we made. Look at our paper. And 1, 2 rows, and then 1, 2, 3. 3 columns. Okay. Okay. So just set up the matrix. Here they use general X1 and X2 terms. Again, you don't have to use it if you don't want to. I can also show you how to do it on your graphing calculator if you want. I don't know what machines you guys have. Yep. Just punch it in here and solve. So X1 is technically RA, X2 is technically RB. I'll write down on the paper that A is equal to -1 and B is equal to 1. Okay. You can solve it by hand, of course. I know you've all done that already before at some point. I'm not going to test the one. I think we implemented this class. Do you guys have this one? Do you have an 83 or 84? One of these guys. They can both do it. Technically, this is the one we recommended for this course. I don't know if you have one or checked one out or bought one. Let's see if we can do it. So if you go to second matrix or second math, there's a matrix option on top. You can go to edit and then say, okay, I have 2 rows and 3 columns. Fill it in. 1, 1, 0, -2, 3, 5, and then quit. Go back to the matrix menu here. There's a big glare there. When you're in the menu, you go to math. These are all the operations for matrices. So you go to RREF. This is technically the name for row reduced echelon form, meaning it solves it for you, basically. So just go back in there, call the matrix, that'll solve it. Notice how it has -1. Everything on the right-hand side will be the answer, -1 and 1. Okay, so A equals -1, B equals 1. That's how you read this. Okay, is that clear? You can do the same thing with this guy, the 83 and 84, we do the same thing for you. You just go into the matrix menu, go to edit, choose one, put in your dimensions. 2 by 3. And you'll do the same thing. Okay, you will punch in 1, 1, 0, -2. -2, 3, 5. Once it's there, you quit. Second matrix, go to math. See how it's very similar to the last example or the other calculator. Go down until you find RREF. input your A, enter. So again, this means A is equal to -1 and B is equal to 1. If you want me to send you videos on how to do this, I can. There's a bunch of them on YouTube. If you need me to show you on how to do it together, we can as well. I can also show how to do this via algebra using substitution and elimination on the equations if you want to go that old school route. It's up to you. I'm not going to tell you how to do it. My suggestion is use a matrix solver. It's the fastest, especially when you start having A, B, C, D, like those types of questions. Like you don't want to spend all that time on doing all that substitution stuff. Anyway, any questions on that stuff? Yeah, Benjamin, you can check these out. I'm pretty sure. I'll make sure to post information on that. The TI-36 Pro, this guy, I think they're only, well, they used to be like $12. I think they might be 20 now. I don't know. Prices are weird lately, right? So probably $20. If you want a graphing type or a little more, if you really, I'm not telling you to get one of these. But these are anywhere from 100 to 130. So I don't really like recommending that because it's expensive. If you really want a graphing type, I would just go to OfferUp or a pawn shop because the people trade them in all the time. If you want to go the cheap route, that's just my suggestion. But you can check them out. You can check out this guy from school or buy it for $20. It is up to you. Any questions on the math here? Back to this stuff or the calculator. You guys did them. All right, so basically the answer would be, right, we didn't really finish. The answer and the whole point of what we're doing here, like, since we get bogged down in the math, what the heck are we doing again? We are separating this fraction to two fractions, and we're plugging in those numbers. That makes this true, makes it equal. So there's a theorem that says that there exist two numbers that will let you separate this, and we're trying to find those two numbers, and that's going to be this. That is what we did. So -1 would go here, 1 would go here. Is that clear? What the goal is? Okay. So let's go and see if I can fit the answer in here. So we are decomposing this guy into -1 over x plus 3 plus 1 over x minus 2. That's it. This is the answer. Here, the right hand side. Remember, half the credit is just setting it up properly. If you set it up for me and you can't finish it, at least I know that you understand the idea, but you got lost in the algebra. Okay. Let me open the homework so you can see what it looks like in case you haven't yet. Okay. So here's the homework. It starts out with some theory stuff, so I'll let you do that. And then it starts testing you on the setup. Okay, so it says, okay, well, you have two distinct factors. How would you set this up, right? You would set this equal to, what do you guys think? A, B, C, or D? Right, they are distinct linear factors. just like case 1. Yeah, it's going to be C, right? So A over the first factor, which is the X, and then B over the second factor. That's it. That is, again, half the credit of the question. Check this one out. This is a repeated linear factor, right? So I'm going to have to count up until 2. They're not linear. This one's not linear. So this is case 2, combined with an extra term. So right away, I would say D makes no sense, right? What do you guys think? Remember we said that if we had, let's say I make a new question here. Oh, computer's freezing. Let's say I had x cubed over x minus 4, or make it different, 3. You would have to count all the way up until 3. You would have a over x plus b, right, b over x squared, and then I gotta go all the way to 3. And then I do d for the last one. Does that make sense? So whenever you have a power that's not 1, we call that a repeated linear factor. Right? Because if this original one is linear, it just has a 3 on it. So go 1, 2, 3, and then you do this part. Okay, so which one do you think it's going to be? All right, we have a 2. It's going to be B, because it goes 1, 2, and then does the last term. See that? Does that make sense? Do you see why it is B? Okay, so that's how you deal with repeated. So let's go back to the notes. Right, repeated linear factors. That's what we're doing here. They put the 2 on the other one though, right? So we had to do 1 and then 2, right? And this one is just a single one, so it's whatever. A over that first one, and then we deal with the repeated part. Okay. Once you set it up, we have to do the algebra again. Any questions on this setup or the setup in the homework? Okay. Let me know. You guys cool on this page? I'm gonna turn the page. All right. Really quick, let me show you the alternate method. Let's repeat. So this is still example 1. Let's repeat Step 3. All right, so in step 3, we had 5 equal to a times x minus 2 plus b times x minus 3, right? And I said that there was 2 methods, and I showed you the one that works every single time. Now I'm going to show you the shortcut that works sometimes. So basically what you can do is say, you know what, let x equal 2. You can choose whatever you want. I'm choosing 2 because that will make this go to 0. See what I mean? So that'll give me 5 equal to a times 2 minus 2 plus b times 2 minus 3, which will be 0 minus b. Oops, sorry. So x plus 3, what is that? Yeah. Sorry about that. So solve for b, right? Divide both sides by 5. And that'll be 1, which we already knew the answer, right? B is equal to 1. So then do the same thing to get rid of this term. So let x equal to -3, and then we get 5 equal to a times -3 minus 2 plus b times -3 plus 3. So notice how this will go to 0, and then we can solve for a, just like we did earlier. Does that make sense? This is called the Heaviside method. I don't know if the homework will do one or the other. I forget. But I need you to know that the one I showed you first always works. This method can be a pain if you use it at the wrong time. If you use it in an example like this, then it's super easy, but it has to be the right example. -3 minus 2, and that's 0. So solve for a, and you see that a is going to be -1, right? Just like earlier. So there's my 2 solutions that we already have. Any questions on the Heaviside method? I went a little fast there, so let me know. Okay. Oh, somebody up here. Okay. Anyway, those are the 2 methods. So let's move on to case 2. And I think we'll see how it goes. Are you guys cool on this page? Okay, I'm gonna turn the page up. All right, so let's move on to case 2. repeated linear factors. So they give us this guy. X cubed minus 2x squared plus x. You can factor that into x minus 1 times x minus 1. Yeah. So you first factor the x out, and then you factor this into these two. That's where the repeated pops up from. So right here you get x times x minus 1 squared. So in the notes I already gave you, that's what they got here. They skipped from here to there. They didn't show any factoring steps. Once it's factored though, you apply the case 2, right? So get back to the paper. Wrote that all weird. Okay, so the first term is just a over the x, right? Then you start with this one, but you count starting at 1, and you go all the way up until whatever number is there. So b over x minus 1 plus c over x minus 1 squared. You don't have to put parentheses, but I'm putting them just so you see this is a 1 and a 2. Okay, you guys cool so far? Right. So that's step 1 is the setup. Step 2, cancel fractions. Multiply by the LCD. And we said it's always going to be whatever's over here, right? So multiply the right hand or left hand side by x times x minus 1 squared. So x times x minus 1 squared. And the first term times the same thing. And the next term last term. So left-hand side will always cancel this way, leaving you with just the denominator. This will only cancel the x, so I'm left with a times x minus 1 squared. This will only cancel one of them, so I'll be left with b times x minus 1. So these cancels one of those. Okay. This is all times. Let's cancel the entire x minus 1 squared, so I'm left with cx. Any questions on that algebra? Good. So at this point, we're going to multiply stuff out, gather all the like terms, and then create the system. Okay. Step 3, multiply and gather the like terms. So fill this out or multiply this out, you're going to get a times x squared minus 2x plus 1 plus, and distribute this, you get bx squared minus bx plus cx. Distribute the a, and we'll get ax squared minus 2ax plus a plus bx squared minus bx plus cx. Okay, so everything is multiplied. I skipped some basic steps here, but if you have a question, let me know. If you missed it or you're wondering how we got to here. You guys okay? As you can see, this is very tedious, this section. All right. So let's start gathering everything that is the same like term. So there's only one quadratic, right? Oh, two. And then all the x terms. Okay. Step 4 is equate the coefficients. Any questions on step 3? Or the beginning, I don't care where. Good. So look at the quadratic terms. A plus b is equal to the quadratic coefficient on the left. We don't have any, right? So this is equal to 0. Now look at the x terms. You have a negative 2a, b, and c. Do we have an x term on the left? So we set this equal to that number. Okay. Then you look at the constant. We only have 1. Set that equal to the constant. Any questions on the equate the coefficient part? This is basically like the quadratic coefficients, linear, constant. You can actually factor to see it a little bit better. This will have enough space. That makes sense. These are the coefficients of all the x terms. Set them equal to the coefficient of the other side. These are the coefficients of the quadratics. There is none, so that's why it's 0. 0, 2, negative 3. Okay. Any questions on that step? All right. So create the matrix and solve for ABC. That's what I recommend to you. Let me turn the page in a moment. That's cool if I turn the page. Okay. We had a plus b equal to 0, negative 2a plus b, right? Minus b plus 0. Negative 2, 3. Oh, 2. Yeah. I think it's lunchtime, making mistakes here.
I have a question.
That's what we had in the other paper. Change it into a matrix. That'll give us 1, 1. There is no c, so we put a 0. We have a negative 2, a negative 1, a 1, and a 2. We have an a, but nothing else. So we technically already know what a is. We could figure this out without the calculator pretty easily, because if a is negative 3, what does b have to be? Right, negative 3 plus something, right? Exactly. So we have a, we have b. We could plug these into here and find c if you wanted to. Doesn't matter. Or you can use a solver. Not worry about it. Let's see. So we have a 3 by 4 matrix. 1, 1, 0, 0. when you're punching in negative numbers, if you're using one of these TI calculators, make sure you use the negative symbol, not the subtraction symbol. You will get an error if you put -2 instead of -2 or whatever. That makes sense. I know that sounds silly, but you're going to get an error and you're going to wonder why. That's going to be why. All right, so punch them all in, quit. Go back to the matrix menu, go to math, and go all the way down to RREF. Then press matrix menu again, choose the A and solve. So we knew that A was -3. We knew that B was 3, right? C is -1. Okay, any questions on this problem? Okay, so sum it all up, we had this, and we set it equal to A over X plus B over X minus 1 plus C over X minus 1 squared, which will be -3 over X plus 3 over X minus 1 plus -1 over X minus 1 squared. So this is the answer they're looking for. All that other work is just setting it up and then finding the ABC. Any questions on any of the steps? Okay. So as you can see, the actual work to solve for ABC is going to be the same. The only thing that changes is the setups. That's why I want to make sure you know your setups. The only one that's a little different is this one, case 5. I don't like this one. So let's do this one and then we'll stop here for today. Do have to get to the doctors pretty soon. Let's see. Wait a second. You guys cool on this page or not yet? All right, let's do the long division. You guys remember how to do long division? Okay, so this happens whenever the power up top of the numerator is higher. The degree of the numerator is higher than the denominator. That's funny, Sylvester. All right, so let's go, let's do some division. So 5 goes into 59 how many times, right? The pattern is what matters here. You first check the first one, right? Goes into the 5 ones. 1 times 5 is 5. And then you do a minus. You guys remember doing this way back when? You subtract. Bring down the 9. Then you start over. The pattern begins again. 5 goes into 9. 1 time. 1 times 5. You get a 4. And then 5 doesn't go into 4, so you bring down another number. 5 goes into 45 9 times. 9 times 5 is 45. 0 remainder. So this pattern is what you need to remember. Okay. All right, so we have x cubed minus x plus 3 over x squared plus x minus 2. So notice how the degree on top is bigger, right? 3 and this is a 2. So we have to do long division. 5 sucks. Yeah, Wolfram's pretty legit. Let's see here. X squared plus x minus 2. You know what? Maybe I'll do it down here. The bottom one is dividing into the top one. Yeah, I use Wolfram whenever I need to factor something really disturbing or I'm double checking things. This is being divided by that. So the pattern is going to be just like this, but you have to only divide by the first term. Okay. I'm going to use this sign as my stretch word. So x squared goes into x cubed how many times? Right, so you divide it. It goes in x times. That makes sense? Just like over here, we did 5 into 5, 1 time. 1 times 5, negative 5. The only thing that we need to add, I forgot to mention, it needs to have all the powers. So if it's a 3, you need to have a 2 and a 1 and a 0. This only has 3 and a 1. So you put in a placeholder. That makes sense. It's the same thing. It just makes things a little easier so you don't mess it up. Okay. So x times these 3 terms, that's going to be x times x squared, that is an x cubed, and then you switch the sign, right? Just like they did the 5. Switch the sign. X times x minus, though, x times negative 2. That'll be opposite. You just switch all of them. And then you add them, just like 5 minus 5 was 0. X cubed minus x cubed is 0. 0 minus 1 is negative. Negative 2 plus 2, 1, 3. Any questions on the pattern or this step here? You see how it's the same, right? Almost the same. So at that point, it's basically at this step here. You start over. 5 goes into 9. X squared goes into x squared. How many times? So -1 times. That goes here. Now -1 times each of these terms. Be negative x squared negative x plus 2. But you have to subtract the whole thing. That's going to switch the signs again. So the hardest part, I think, is remembering the pattern, but also keeping your sign straight. So minus minus is going to be plus, right? Essentially, this is what we're actually doing. This would be 0, 2, 1. So if you once you distribute the minus, you're going to get this. So the result will be these cancel, and I get 2x plus 1. So that's our remainder because we can't divide any further. So basically what we've done is we've changed this original into x minus 1 plus 2x plus 1 over the divisor. So we're going to apply partial fractions to this part here. Actually, just this part. So what long division does for you is it reduces the fraction because it's improper and gives you a proper type. Okay. Let's go back to the notes. So that's how they got this. See how they skipped all that in that first step? They don't explain anything. They just said, okay, we give you this, turns into this magically. Now apply partial fractions. So I showed you how to get to here. But you're only going to do partial fractions on this term here. That's what they do on this step. Okay. So you factor the denominator. They are distinct. You do A and B, and you do the same process as case 1. Okay. Is there any questions on that? But you see how the hard part is that long division, right? After that, it's the same thing. You have to first remember how to do long division. We're basically reducing that fraction. Okay, and that's what we did here. We divided this answer on top, the quotient goes here. The remainder divided by the divisor is there. Any questions on that? Okay. Let's look over the homework just a little bit before we call it a day. Ready? So again, first it starts off with you just setting it up. Then I want you to actually do do the entire thing. So once you get to 9, 10, 11, this is basically what we're doing right now in our notes. Okay. The entire process. Let's see here. 15 is the improper fraction case 5 that we just did. The 15 is going to be the annoying one. And 16, the last two. The last two in your homework will be long division type. The rest will be cases 1 through 4. Okay. We're going to stop here. We'll try to do a few more examples tomorrow. Since we're slightly behind, I am going to keep you till, what is it, 2:30, right? Yeah. Yeah, it's about 2:35. So tomorrow and Thursday, expect to be here till 2:35 for sure. Okay. If there's time, I would try to leave some, because because of the whole Monday thing, and today my doctor stuff. I'm not sure if we have enough time to do homework problems together this week, but I'm going to try. So we'll see how it goes tomorrow. I'll let you know. But let's look at our schedule just so we have an idea of what we're supposed to be. Can you guys see the syllabus? Okay, so this is a 5-week course, so things go by really quickly. You've got to be doing math every day. Don't take a break. You can take a break when the class ends. If you get distracted, you might fail. Be careful. Technically, we should already be about here, 6.2. We're not. We are halfway through here. So tomorrow and Thursday, I'm going to be doing all of this. So I recommend just try to look it over. Look, I don't expect you to be a pro or a master at this just yet, but just look over the first few examples in each section and see, okay, what is this section about? What are they even talking about? That's all I want you to do. Just figure out what is this section about. That way, when we talk about it tomorrow and Thursday, it'll make a little more sense. I'm hoping you looked over partial fractions so you can see what I mean. It does help a little bit, right? If you look over, once we talk about it, it'll make more sense. You might also have questions. If you start trying to do problems and you get stuck, well, you have a bunch of questions to ask if you start ahead of time. That is what my instructors always told me to do. I never did it, and I wish I did, but it is helpful. Next week, we will finish chapter 6 and then review. So exam 1 will probably be due. I'll probably open it on Monday or Tuesday, and I'll let you do it anytime that week. Okay, but I'm going to expect you to have an exam done by next weekend. Not this weekend, but the following. That's the latest you should be doing the test. Because not only do you have to do the test, you also have to get chapter 6 and start chapter 7 by next week. So there's not much time to slack. We don't have much freedom. And then as soon as that week ends, we'll finish chapter 7, then you have another test. Then right after that, we do chapter 8, and we have the last test 3. Then we review for the final. So it's going to come really quick. It's going to be a lot of material. So try not to get distracted. Okay, you got to do homework every single day. If there's a genius, you have to. Great, but I'm not, and I have to do a lot of work during summer sessions for my classes. All right. You guys have any questions? All right, if you have no questions, feel free to head out, and I'll try to post this video and notes as soon as possible. Okay. Send your YouTube link on Remind, and the PDF will be on Remind as well. Yeah, just partial fractions today. I recommend you look over the next 2 sections just in case.